Hello, hi everyone. Welcome to the brand. This is Vatsva sir. Today topic is light reflection and diffraction. So we will discuss light reflection and diffraction. Light is a form of energy which gives the sensation of sight. Okay, when light incident on it, so plane mirror, this incident ray, reflected ray, the light which is perpendicular to the plane surface is called normal line. Incident ray, reflected ray, and this one is a normal. Okay, so when light incidenting on the surface, it reflect back, okay, into the same medium. The bouncing back of the light from the reflecting surface is called reflection of light. Okay, so incident ray, reflected ray, normal line. The phenomena of bouncing back of the light from the reflecting surface is called reflection of light. Okay, so here now you can see linear angle is 180 degrees. Linear angle is 180 degrees. Okay, so now you can see angle of incidence, the angle between incident and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. Angle between this undeviated line, angle between undeviated line and reflected ray is called angle of deviation. So here you can observe angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Okay, because it is a linear angle. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So from laws of reflection, laws of reflection, from laws of reflection, so you can observe here. So first point is incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. So from that, so we can write this equation. So we can write this equation like this. So you can observe here. That is angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. Okay, so here you can observe. So incident ray, reflected ray, normal line. This is the incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. So magnification for a mirror is minus b by u. For lens is b by u. For mirror, negative sign will come. For lens, positive sign. Okay. So here you can see incident ray, reflected and normal line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. Angle between reflected and undeviated line is called angle of deviation. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Okay. So now you can observe laws of reflection. Incident ray, reflected ray, normal line lies on the same plane. Angle of incidence is equal to angle of reflection. So from that here we can write angle of, instead of angle of reflection I am writing angle of incidence. So angle of deviation equal to 180 minus 2 angle of incidence. Negative sign indicate image is real and inverted. Okay, so positive sign indicates image is virtual, erect, and virtual. Okay, so here loss of reflection. Next, now we will discuss about regular reflection and irregular reflection. So now regular reflection. So regular reflection takes place on smooth surface, whereas irregular reflection takes place on rough surface. So I am taking this a smooth surface. So here you can observe. So this is about incident parallel light rays. So these are incident light rays. These light rays are parallel to each other. So then reflector light rays are also parallel to each other. The type of reflection is called regular reflection. So here you can observe. So regular reflection, because incident light rays are parallel, then reflector light rays are also parallel to each other. So this type of reflection is called regular reflection. Okay. So coming to irregular reflection, irregular reflection, irregular reflection. So irregular reflection takes place on rough surface. So I am taking this a rough surface. So now you can observe incident light rays are parallel, but reflector light rays are not parallel to each other. Okay, here incident light rays are parallel, but reflector light rays are not parallel to each other. So this type of reflection is called a regular reflection. This is a regular reflection because so incident light rays are parallel, then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. Whereas irregular reflection, incident light rays are parallel, but reflector light rays are not parallel to each other. So this is called regular reflection and irregular reflection. So now we will discuss about object and image. Object and image will discuss. So here you can observe so here you can see light rays. So this, so you can observe here. So these are the incident light rays. These are the incident light rays. So incident ray 1, incident ray 2. So after reflection, these reflector light rays are meeting at one point. After reflection, reflector light rays are meeting at one point. That's why it is called real image. We are extending this incident light rays, extended incident light rays. Okay. So we are extending. Okay. So these extended incident light rays are meeting at one point there. So object is there. That is a virtual object. So object is real, image is virtual, object is virtual, image is real. So in this case you can observe, so this is the real object and a virtual image. Real object and virtual image. So why is here like this? Because from this point light rays are coming. From this point light rays are coming. So this is a real object. So after reflection, we are extending the reflector light rays. Extended reflector light rays are meeting at one point. That's why it is called virtual image. Virtual image. Once again, real image, because reflector light rays are meeting directly. Here extended incident light rays are meeting. That's why virtual object. Okay, real image and virtual object. Here, from this point, light rays are coming. That's why it is called real object. So reflector light rays are meeting at one point. That's why it is virtual image. So this is about here. This table is very important. So you must remember this table. Okay, because here, by seeing this table, by looking at this table, we can understand these two diagrams. So object is real. Object is real. This is a real object. So virtual image. Virtual image. Object is virtual. Object is virtual. Image is real. Image is real. So easily we can identify. So this table is very important. So make sure that you are remembering this table. Next one. Next one, so we'll discuss one more, that is nature of the image formed by the plane mirror. So here you can observe, in this case we can conclude that object is real, image is virtual. First point. Point number 1, object is real, image is virtual, object is virtual, image is real. Point number 2, so the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Okay, so object distance is equal to image distance. And third one is height of the object is equal to height of the image. And fourth one, so magnification of the plane mirror is +1. And fifth one is, it also shows lateral inversion. Lateral inversion. So first point you can observe here. Okay, object is real. If object is real, image is virtual. If object is virtual, image is real. Okay, now vice versa in plane mirror. Second point, the distance between object to mirror is object distance. The distance between mirror to image is called image distance. So in plane mirror, object distance is equal to image distance. And coming to the height of the object, okay, size also we can say height of the object is equal to height of the image. And magnification of the plane mirror is +1, because so here virtual, erect and same size of the image will be found. So in plane mirror, so that's why we are taking virtual, erect and same size. And coming to the lateral inversion, so lateral inversion. So what is lateral inversion? The phenomenon of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. Okay, so this mirror image is called lateral inversion. This mirror image is called lateral inversion. I hope these points are clear. So this is about characteristics of the image formed by the plane mirror. So object is real, image is virtual, object is virtual, image is real, object distance is equal to image distance, and height of the object is equal to height of the image, and magnification of the plane mirror is +1, and also it shows lateral inversion. So next we will discuss about spherical mirror. There are two types of spherical mirrors. One is concave mirror. So now you can observe, here I am explaining about spherical mirrors types. The mirror which is in the form of curved surface is called spherical mirror. So there are two types, concave mirror and convex mirror. Now I will explain about concave mirror. Concave mirror here and convex mirror. Okay, convex mirror. Here convex mirror. So concave mirror whose reflection takes place inward is called concave mirror. Whose reflection takes place outward is called convex mirror. Concave mirror is also known as converging mirror. So here you can observe. So here you can see. So when a light rays incident on it, after reflection, those light rays are moving towards the principal axis. Like this. Here, after reflection, light rays are moving away from it. So here you can see. So concave mirror is also known as converging mirror. Here you can see concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. Concave mirror, converging mirror, converging mirror, and convex mirror is also known as diverging mirror. Diverging mirror. Okay, so concave mirror is converging, convex mirror is diverging. Now, so we'll discuss about ray rules of concave mirror. So instead of that, before that, we will discuss about terms related to spherical mirror. Terms related to spherical mirror. So this is the center of the imaginary sphere in which mirror is a part. The midpoint of the mirror is called pole. So this is called radius of curvature. So here, after reflection, all light rays are meeting at one point. So that is called focus. So the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. Focal length. And width of the mirror is called aperture. Okay, so here you can, first point is center of curvature. Second one is pole. Third one is focus. Fourth one is focal length. And fifth one is aperture. And the sixth one is principal axis. Principal axis. And the seventh one is center of curvature, pole, focus, focal length. So the distance between focus to pole is called focal length. And width of the mirror is called aperture. And radius of curvature. Radius of curvature. Radius of curvature. So you can check here the center of the imaginary sphere. The center of the imaginary sphere in which mirror is a part is called center of curvature. So the midpoint, so this is the mirror. This is the mirror. The midpoint of the mirror is called pole. So after these are the light rays are coming from infinity, these two. After reflection, these light rays are meeting at one point. These reflector light rays are meeting at one point. That is called focus, capital F. So this is a capital F. The distance between focus to pole is called focal length, small f. And width of the mirror, this total reflecting surface is called aperture. And the principal axis, the line joining of center curvature and pole. Line joining of center curvature and pole. Line joining of center curvature and pole is called principal axis. The distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. Okay. Distance between center of curvature to pole is called radius of curvature. Clear? So these are the terms related to spherical mirror. Terms related to spherical mirror. Okay. So once again, center of the imaginary sphere in which mirror is a part. So pole midpoint of the mirror, focus. So after reflection, all light rays will meet at one point, that is called focus. Focal length, distance between focus to pole is called focal length. Width of the mirror is called aperture. Principal axis. Line joining of center curvature pole is called principal axis. Radius of curvature, the distance between center curvature to pole is called radius of curvature. So these are the points related to terms related to spherical mirror. Now we will discuss about ray rules of concave mirror. So now we will discuss ray rules of concave mirror. So ray rules of concave mirror we'll discuss now. Concave mirror and convex mirror also. So ray rules of concave mirror and convex mirror both we will discuss at a time because similar ray rules only. Point number 1, concave mirror. So till now we discussed pole, focus, center of curvature, radius of curvature, everything we will mention here. Okay, so pole, concave mirror. So focus, center of curvature. Light ray is coming from infinity after reflection passes through focus. Light ray is coming from infinity after reflection passes through focus. So first ray rule. Second ray rule is so pole, focus, center of curvature. Light ray is passing through focus. And third one, so pole, focus, center of curvature. So here, these are ray rules of concave mirror. So here you can observe. Light ray is coming from infinity after reflection passes through focus. Light ray is passing through focus after reflection moves towards infinity. Light rays passing through center of curvature. After reflection, it retraces its original path. Light rays incidenting at the pole, it reflects back. Okay, now coming to the concave mirror. So here you can observe in this case. So this is the concave mirror. So concave mirror and convex mirror. This is a concave mirror and this one is a convex mirror. So here you can observe light rays coming from infinity after reflection passes through focus, and here light rays passing through focus after reflection moves towards infinity. Here light rays passing through center of curvature after reflection retraces its vertical path, so it moves in the same direction. So here you can observe light rays incidenting at the pole after reflection, reflecting back into the same medium. So here you can observe in this case, light rays coming from infinity after reflection passes through focus. Light rays coming from infinity after reflection passing through focus. And here light rays coming from source after reflection moves towards infinity. So like this. So it is passing through focus, incident ray. Here light ray is passing through center of curvature, it retraces its original path. Here light ray is incident at the pole, it reflect back. So concave mirror and convex mirror. Ray rules of concave mirror and convex mirror. Next, I'll discuss about image formations of concave mirror and convex mirror. So first we will discuss about concave mirror, image formations of concave mirror. So very important, we will discuss those. So now we will discuss about image formations of concave mirror and convex mirror. So let's discuss. Image formations. Concave mirror. So image formations by concave mirror. Now we will see. So pole, focus and center of curvature. Object is at infinity. So light rays are coming from infinity. Light rays are coming from infinity after reflection. Object is at infinity. Image is forming at focus. Nature of the image is real and inverted. Size of the image is highly diminished. Coming to second one. So pole, focus and center curvature. Light ray is coming from light rays are coming from the beyond the center of curvature. So it is passing like this. So object is placed beyond C. Object is placed beyond C. Image is forming between C and F. Image is forming between C and F. Nature of the image is real and inverted. Size of the image is diminished. Okay, so coming to third one. So pole, focus, center of curvature, pole, focus and center of curvature. Object is placed at center of curvature. F and C. So object is placed at C. Image also will form at C. Nature of the image is real and inverted, and size of the image is same size because image is forming at C itself. So one light I am taking like this. So it passes through focus. So another light ray is passing through pole. It will be incidenting at the object is placed at C. Image also will form at C. Nature of the image is real and inverted, and size of the image is same size. Coming to the fourth one. So pole, focus, center of curvature. Object is placed between C and F. Image is forming beyond center of curvature. C and F. So one light I am taking like this. It passes through focus. So passing through focus. Another light ray is incident at the pole. It reflects back. Okay, object is placed between C and F. Object is placed between C and F. Image is forming beyond center of curvature. Nature of the image is real and inverted, and size of the image is enlarged. Object is placed between C and F. So image is forming beyond C. Beyond C, nature of the image is real and inverted, and coming to size of the image is enlarged. So compared to object, image size is increased. Okay. So next one, fifth one. So pole, focus, center of curvature. Object is placed at F. Object is placed at F. So one light ray I am taking like this, it passes through focus. Another light ray is incidenting at the pole, it reflects back. Object is placed at F, image is forming at infinity. Nature of the image is real and inverted, size of the image is highly enlarged. Highly enlarged. Highly enlarged. And coming to the sixth one. Coming to the sixth one. So pole, focus, center of curvature. So object is placed between P and F. So this is about a concave mirror. You can check once. So here you can observe object is placed at infinity. So image is forming at F. Object is placed at infinity. Image is formed at focus. Nature of the image is real and inverted, and size of the image is highly diminished. So coming to the second one, object is placed beyond center of curvature. So image is forming between C and F. Nature of the image is real and inverted, and size of the image is diminished. And coming to here, third one, object is placed at C. Image also will form at C. Nature of the image is real and inverted, and size of the image is same size. And here coming to fourth one, object is placed between C and F. Image is formed beyond center curvature. Image is formed beyond center curvature. Nature of the image is real and inverted, and size of the image is enlarged. Compared to the object, image size is increased. Coming to the fifth one, object is placed at F. Image is formed at infinity. Nature of the image is real and inverted, and size of the image is highly enlarged because these two lines are parallel lines. Parallel lines meet at so we are assuming actually parallel lines will meet at infinity like that. So that's why it is highly enlarged. Coming to here, this is very important. So object is placed between F and P. Image is formed behind the mirror. Behind the mirror. Nature of the image is virtual, erect and enlarged. So compared to the object, image size is increased. Compared to the object, image size is increased. Okay. So that's why we are calling it is enlarged. Okay, virtual erect. So if you observe these two cases, fourth and sixth, so in the fourth case, image is enlarged and real and enlarged, real and inverted and enlarged. Here, virtual, erect and enlarged. So in concave mirror, there are two types of images will be forming. Those are real inverted and enlarged, virtual erect and enlarged. So which are those cases? Draw the image diagram, okay, and explain with the comparison. So if you draw these two diagrams after drawing, so you can compare these two images and you can explain. So object is placed between C and F, image will form beyond center curvature. So nature of the image is real and inverted, size of the image is enlarged. And here object is placed between F and P, image will be formed behind the mirror. Nature of the image is virtual, erect and enlarged. Okay, so these two are very very important. Make sure that so you are practicing these two. So concave mirror image formations. Next one we will discuss about convex mirror image formations. Let's start. So now convex mirror image formations. Only two cases are there in convex mirror. So we'll see. Object is placed at infinity. Image is forming at focus. So here you can observe. So in this case, object is placed between infinity and pole. So image is forming between P and F. Nature of the image is virtual, erect and diminished. So these two cases you can observe carefully. Okay, only these two cases. Object is placed at infinite, image is forming at focus. So image is nature of the image is virtual, erect and highly diminished. Highly diminished. And coming to here, object is placed between infinity and pole. So image is forming between P and F. So P and F. Nature of the image is virtual, erect and diminished. So virtual, erect and diminished. Okay. So if you like the content, if you like the channel, do like, share and subscribe to Student the Brand. So now we will discuss about image formations. So here you can observe one thing. So in the direction of incident rays, all are positive. Object distance, image distance, focal length and radius of curvature, all are positive. Opposite to incident rays, all are negative. So object distance, image distance and focal length, radius of curvature. So above the principal axis, height of the object and height of the image positive. Below the principal axis, height of the object and height of the image is negative. So this is about new Cartesian sign conventions. Once again, in the direction of incident rays, object distance, image distance, all are positive. Opposite incident rays, all are negative. Above the principal axis, it is positive. Below the principal axis, it is negative. So new Cartesian sign convention, new Cartesian sign convention, all distance are measured from the pole. Distance are positive along the instant rays. Distance are negative opposite to instant ray. Distance are positive above the principal axis. Distance are negative below the principal axis. The Cartesian sign convention. So this is about new Cartesian sign conventions. Next, so I'll discuss mirror formula, magnification. So mirror formula 1 by f equal to 1 by v plus 1 by u. Magnification equal to height of the image by height of the object, that is nothing but minus v by u. Okay, so this is about mirror formula magnification. This is about mirror formula 1 by f equal to 1 by v plus 1 by u. Magnification equal to height of the image by height of the object minus v by u. Okay, so next one we will discuss about lens. Let's start about lens. So do like, share and subscribe to Student the Brand. If you like the content, if you like the explanation, if you like the channel. Okay, so what is the question? So now let's discuss refraction. Okay, refraction. So refraction is nothing but the bending of the light, that the interference of the two media. So here I am considering this is a rarer medium and denser medium. Rarer medium and denser medium. This is the rarer medium and denser medium. When light ray is coming from rarer to denser, so it bends towards the normal line. So here you can observe the light ray will bend towards the normal line, because when it is moving from, so when it is, okay ma, so I'll discuss electricity. Okay, so Do like, share, and subscribe my channel, so you'll get notifications. So click on bell icon. I will be taking frequently related to classes regarding 10th class, CBSE grade 10 physics and electricity, light chapter, magnetic effects of electric current, and human and colorful world. So I'll be clarifying the concept. I'm explaining the concepts related to problems also. So just follow. After this, after completion of this topic, I'll discuss electricity topic also. Okay. So now this the angle between incident ray and normal line is called angle of incident. Angle between refracted and normal line is called angle of refraction. When one light ray is moving from rarer to denser, it bends towards the normal line. Okay. So here, so rarer medium, denser medium. Light ray is moving from denser to rarer, denser to rarer. So angle of incidence and angle of refraction. So here you can observe in this case, okay, so angle of incidence is greater than the angle of refraction. So here in this case, angle of refraction is greater than the angle of incidence. Why, sir? Why it is like this? Because here light ray is moving from rarer to denser. So in the denser medium, speed of light is less compared to the rarer medium. That's why, so light ray is bending towards the normal line. Light ray is bending towards the normal line. Here you can observe light ray is moving away from the normal line. So angle of refraction is greater than the angle of incidence. So when it is moving into rarer, denser to rarer, speed is increasing. That's why refracted ray is moving away from the normal line. Refracted ray, this is a refracted ray moving away from the normal line. So that's why angle of refraction is greater than the angle of incidence. And coming to here, so when light ray is moving from rarer to denser in this case, so here in rarer medium speed will be more when it is entering into the denser medium. So this is the denser medium. When it is entering into the denser medium, speed is decreasing. That's why it is this refracted ray bending towards a normal line. Refracted ray bending towards a normal line. So that's why angle of incidence is greater than the angle of refraction. So compared to this angle is more. That is a symbol. And here, so light ray is moving from denser to rarer, denser to rarer. So angle of refraction means compared to this angle, angle of refraction is greater. So this is about refraction. So the bending of the light ray at the interference of the two media is called refraction. The bending of the light ray at the interference of the two medium. So here this is a rarer medium, denser medium. So here we can take this medium is water and glass. Suppose example we can take. So this I am taking as a water and this is glass. So we can take any medium, not only water and glass. So but two different mediums I am taking. So if the light ray is moving from one medium to another medium, means different mediums, then only changing of the light ray takes place. Bending of the light ray takes place. So path of the light ray changes. Path of the light ray changes. Okay, so that is the reason. So that is called refraction. That is called refraction. So if it is moving from same medium, okay. So if I take water and water, so rarer medium water, denser medium also water. So light ray will passes along the normal line. Even here also, if you are taking the same mediums, light ray, so there won't be any deviation. And one more thing, if the light ray passing along the normal line also, no refraction. Only two cases refraction does not take place. So point number one is, so two mediums must be same. If it is same, no refraction, and light ray is passing along the normal line also, no refraction. These two cases. So this is about refraction. Okay. Next one we will discuss about total internal reflection and critical angle we'll discuss. So do like, share and subscribe to Student the Brand. If you like the content, if you like the explanation, so share it to your friends. Ask your friends to join to the class. Check once my channel. So check all the physics related videos. Rarer medium, denser medium. Source. So here I am taking the normal line. So light ray passes along the normal line. Making 90 degrees. So here you can observe one thing. Here you can observe, so this is the incident ray, refracted ray. Normally if the light ray is passing from denser to rarer, this is the rarer medium, speed of light is more in the medium, rarer medium, and speed of light is less in the medium is called denser medium. So if the light ray is passing from denser to rarer, so here it moves away from the normal line. This is the normal line. Okay, so here this is the incident ray. So coming from denser to rarer, denser to, so this is a normal line. So in the rarer medium, the refracted ray makes 90 degrees with the normal line. So refracted ray makes 90 degrees with the normal line. Then this angle is called critical angle. Then that angle is called critical angle. And here you can observe, so here you can observe light rays passing from denser to rarer. So at the point of interface, so here it makes more than 90 degrees. Here 90 plus theta, so more than 90 degrees. Then this refracted ray reflect back into the same medium. That is denser medium. So same medium, denser medium. Total internal reflection. Total internal reflection. Understood? Total internal reflection. Once again, light ray is passing from denser to rarer. It moves away from the normal line. So this is a normal refraction. So if it is passing from denser to rarer at the rarer medium, in the rarer medium, refracted ray passes along the surface, gauges along the surface, moves along the surface, or makes 90 degrees with the normal line. And here, so the refracted ray reflect back into the same medium after making more than 90 degrees. So 90 plus theta, this 90 degrees with the normal line. So this the reflected ray, so making 90 degrees with the normal line. So more than 90 plus theta. So more than 90 degrees, then it will be reflected back into the same medium. Okay. So this is the total internal reflection. Total internal reflection. I hope it is very clear. Okay. So this is about two phenomena. Next one. So we'll discuss about a glass slab. Glass slab is very, very important. So make sure that you are learning that. Glass slab. So glass slab. Okay, so here you can see. So which one we are discussing? Glass slab. So I am taking this the glass slab. Okay. So incident ray, refracted ray, normal line. So this the incident ray and normal line I am taking here. This is a normal line and refracted ray, and again it is coming out emergent ray. If you are extending this light rays, okay. So here this is called lateral displacement. Lateral displacement. The distance between lateral displacement, lateral displacement. So angle between incident and normal, angle of incidence, angle of refraction and normal line, angle of emergence, glass slab, rarer medium, denser medium, glass slab. Okay. So now you can observe here. So this is incident ray, refracted ray, normal line. So incident ray, refracted ray, normal line. So when light ray is moving from rarer to denser, so the angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. And the angle between emergent ray and normal line is called angle of emergence. Okay. So this is the initial direction of the incident, this dotted line. So whatever we are drawing, this dotted line represents the initial direction of the incident ray. Initial direction of the incident ray. So the distance between emergent ray and initial direction of the incident ray is called lateral shift. Is called lateral shift. So I hope it is very clear. Once again check. Incident ray, refracted ray, emergent ray. Incident ray, refracted ray, emergent ray. Incident ray, refracted ray, emergent ray. So this is the initial direction of the incident ray. The distance between emergent ray and extended incident ray is called lateral shift. The angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. Now, so lateral displacement, okay. Then what about vertical displacement? Vertical displacement means, so I am taking the beaker. So the person is standing here. Okay. So he placed the coin. So he can't able to see the coin from this position from A. Okay. So I'm pouring water. So after pouring water, so the coin position will rises up. Okay. So the coin position will rises up. So here the position of the coin appears here. This is the position of the coin. Okay. So this is the dotted lines. This are actual lines. So this is called vertical position. Vertical shift. Vertical shift. Vertical shift or vertical displacement. So what is vertical shift or vertical displacement? So the distance between, so actually beaker, empty beaker. So I place the coin at the bottom of the beaker. So person is standing here. After pouring water, so the coin position rises up. So the coin position rises up. So the distance between actual position, this is the coin actual position and this is the apparent position. The distance between actual position to apparent position is called vertical shift. The distance between actual position to apparent position called vertical shift. Okay, so next one. So next one we will be discussing about spherical lenses. Lens. There are two types of lens, convex lens and concave lens. Okay, so I am taking the convex lens. So here this is the convex. So this is the optic center. So this is a part of the lens, and here also part of the lens. Okay, so this side I am taking F1, C1 or 2F1. This is F2, 2F2 or C2. Okay, so this is a convex lens, convex lens, convex lens, and next one concave lens, concave lens. Concave lens. So optic center F1, 2F1, F2, 2F2. Okay, so this is the concave lens. This is a concave lens. Concave lens. So here we can say convex lens is also known as converging lens, whereas concave lens is also known as diverging lens. So why we are saying convex lens is a converging lens and concave lens is a diverging lens? Because whenever light rays are incidenting on it, those light rays will be converged. Okay, so here you can say so here you can observe. So here you can observe in this lens, convex lens. So after refraction, light rays are meeting at one point. Okay, this lens is converging the light rays. Whereas here in convex lens. So concave lens, whenever light rays are incidenting on it, after refraction, those light rays are moving away from it. Okay, so this is about convex lens, this is about concave lens, right? Next, so we'll discuss about ray rules. So ray rules and image formations we'll discuss now. So be ready for it. Now ray rules of convex lens. Ray rules of convex lens we'll discuss. Ray rules of convex lens. Ray rules of convex lens. So this about convex lens. So here you can observe the light ray is coming from infinity after refraction is through focus. Here light ray is passing through focus after refraction, moving towards infinity. Here light ray is passing through optic center, no deviation takes place. So this is very important, importance of the optic center. If the light ray is passing through optic center, no deviation takes place. So it goes in the same direction. So here in the concave lens also same thing. So we'll discuss about concave lens also. Okay. So concave lens also we'll discuss. So ray rules, concave lens. So this is 2f2 concave lens. I'm taking this a concave lens. Okay. So here I'm taking like this. Optic center f1, 2f1, f2, 2f2. So light ray is coming from infinity after refraction. So it diverges. Okay, so here I am considering like this. It diverges. First one. Coming to the second one is so light ray is passing like this. Okay, optic center f1, 2f1, f2, 2f2. Okay, so light ray is coming from or passing through focus. So like this. So after that, so passes. So like this. Okay, third one. Optic center f1, 2f1, f2, 2f2. Then light ray is passing through optic center. So no deviation takes place. Okay. So here you can observe this about ray rules of convex lens and concave lens. Ray rules of convex lens and concave lens. Light rays coming from infinity after refraction passes through focus. Light rays passing through focus after refraction moves towards infinity. Light rays passing through optic center, no deviation takes place. Here light rays coming from infinity after refraction. So actually we can extend this light ray. So if you are extending this one, so like this it will passes here also, here also. Okay. And here you can observe if the light ray is passing through focus after refraction, it moves towards infinity. And here you can see if the light ray is passing through optic center, no deviation takes place. Okay. So this about convex lens and this one is the concave lens. So ray rules of convex lens and concave lens. Next we will discuss about image formations. Image formations of convex lens. Okay. So next we will discuss image formations of convex lens. Okay. So let's discuss about it. So be clear for it. Now we will discuss about image formations. Image formations by convex lens. Image formations by convex lens. Convex lens. Image formations. So F1 and 2F2. So object is placed beyond 2F1. Object is placed beyond 2F1. So one lighter I am taking like this, it passes. So it passes through focus. And another lighter is passing through optic center. So object is placed beyond 2F1. Beyond 2F1. Image is forming between F2 and 2F2. Nature of the image is real and inverted, and size of the image is diminished. And coming to third one. So object is placed at 2F1. Image is formed at 2F2. Nature of the image is real and inverted, and same size. Same size. And coming to fourth one. Here you can see. So optic center F1, 2F1, F2, 2F2. Object is placed at F1. One lighter I am taking like this, it passes through focus. Another lighter is passing through optic center. So object is at F1, image is forming at infinity. So F1 and 2F1, F2 and 2F2. So object is placed between F1 and O. Object is placed between F1 and O. Object is placed between F1 and O. Image is forming same side of the object. Same side of the object. Nature of the image is virtual, erect and enlarged. Virtual, erect and enlarged. Compared to the object, image size is increased. Okay. So check once here. So object is placed at infinity. Image is forming at F2. So nature of the image is real and inverted and size of the image is highly diminished. Next, object is placed. Object is placed at here, second case. This is second case. Object is placed beyond 2F1. So image is forming between F2 and 2F2. So object is placed beyond 2F1. So this object, here is the image. So image is formed between F2 and 2F2. Okay, the nature of the image is real and inverted and size of the image is diminished. Okay, and coming to the third one, object is placed at 2F1. So object is placed at 2F1, image is formed at 2F2. Nature of the image is real and inverted and size of the image is same size. And coming to the fourth one, object is placed between 2F1 and F1. Image is formed beyond 2F2. Nature of the image is real and inverted and size of the image is large. And coming to the next one, fifth one, object is placed at F1. Image is formed at infinity. Nature of the image is real and inverted and size of the image is highly large. Because object is placed at F, image will form at infinity. So parallel lines will never meet. So we assume that those will meet at infinity. And coming to here, object is placed between F and O. Image is formed same side of the object. Okay, same side of the object. So nature of the image is virtual, erect and enlarged. Compared to the object, image size is increased. So these are the image formations of convex lens. Image formations of convex lens. So next we will discuss about image formations of concave lens. Okay, so we'll discuss one. In concave lens only two cases are there. So only two cases, we'll discuss those two cases. So be ready. So only concave lens will discuss. Now we will discuss about concave lens. So convex lens Concave lens. Just now only convex completed. No, we'll discuss about concave lens. Concave lens. So optic center F1 to F1, F2 to F2. Light rays are coming from infinity after reflection. So object is at infinity, image is forming at F1. Nature of the image is real and inverted, and size of the image is highly diminished. So that is the first one. Coming to the second one, coming to the next one. So optic center F1 to F1, F2 to F2. Okay. Object is placed anywhere between optic center and infinity here. So actually we can place so here you can observe object is placed beyond to F1. Object is placed beyond to F1. Beyond to F1. Image is forming between F1 and O. Nature of the image is it's actually a virtual, right? Virtual, erect and diminished here because we are extending the reflected light rays. So virtual and erect. Virtual, erect and highly diminished. And here you can observe here also virtual, erect and diminished. So we cannot say highly diminished but diminished. Okay. So compared to the object, image size is decreased. Understood? So here you can observe object is placed at infinity, image is forming at focus. So nature of the image is virtual, erect and highly diminished. So object is placed beyond to F1, image is forming between F1 and O. So here image will form. So nature of the image is virtual, erect and diminished. Compared to the object, image size is decreased. Next one we will discuss about power of lens, the ability of the lens. Okay. Now, so reciprocal of focal length is called power of lens. P equal to 1 by F. P equal to 1 by F. Reciprocal of focal length is called power of lens. SI unit of power of lens is diopter. So 1 by meter, that is nothing but m power minus 1. So that is 1 diopter. And so convex lens. For convex lens, power is positive. For convex lens, power is positive. For concave lenses, power is negative. Concave lens. Concave lens power is negative. Okay. So this is about light reflection and refraction. Okay. So if you like the content, if you like the channel, if you like my explanation, do like, share and subscribe to Student Brand. So thank you so much for joining and attending and listening my class. So thank you.